Hello guys, this is Sushant from Samartha Vidya, and today we are going to introduce ourselves with engineering mechanics. Engineering mechanics is a subject which you have to study regardless of what field you have chosen in your engineering. So it is going to come basically in your first or second semester, that is in the first year of engineering. So basically let us understand what is engineering mechanics is. So engineering mechanics, it is a branch of science which studies the reactions or the result of forces acting on a body, whether the body is at rest or is in motion. Okay, so engineering mechanics is bifurcated into two parts, that is, first is the static part and the other one is the dynamic part. So as the name static means it is a study in which it will be related to the object in rest. So all the analysis of where the object being in rest will be done in the static section, and in the dynamics it will be all the analysis related to the object in motion. We are going to introduce ourselves with two definitions which we already know in physics, that is a vector and a scalar. A vector is a component which requires magnitude and direction for its definition. Like for example, if I want to say that the car is moving at certain speed, let us say 50 kilometers per hour, then I have to mention in which direction it is moving. So both the magnitude as well, the 50 kilometer per hour, that is a magnitude part, and also the direction. Like if I am saying that the car is moving in the north direction, then that becomes the direction of that. So it requires both the magnitude as well as direction to define any vector. The next thing is a scalar. Now scalar requires only the magnitude, like mass of an object or mass of that car. So the mass of that car will be the same whether it is going in whatever direction. So it does not require any direction as such. It only requires what is the magnitude, let us say. So let us understand the basic thing which is required to understand engineering mechanics is the main component, which is forces. Now force is a vector quantity. It requires magnitude, direction and point of application. Let us try to understand what is basically happening over here. Let me say this is some object. On this a force of 50 Newton is being applied. So the 50 becomes the magnitude part of it. The direction is indicated by this arrow over here, and point of application is this point is the point of application. So where the point is present on that particular body, so the body will react with different things. So if I say this is the center of that body, then because of this application the object will perform a linear motion. So linear motion means that the body will go in a straight line if the point of application is on the center of the body. If the force has been shifted to some other point, let's say this point, now it is no longer acting on the center of the body. So that is why it will perform something else which is called as a rotary motion or a rigid body motion, which we will be studying in this course. So once again, force is defined by magnitude, direction and point of application. So let us understand the definition of force. So force is some external agent which is acting on a body, which has a tendency to change the state of the object and also the shape of the object if the object is not rigid enough to withstand that amount of force. So what do you mean by state of object? So state of object means that it will change from being in the state of rest to the state of motion, or from motion to rest. So that is what is definition of forces. Once we understood what are basically forces, let us see the different types of forces which we are going to study, or which we have to know in this. The first are coplanar forces. So we are going to study the first type is coplanar forces. So co means same, planar means plane. So the forces which are on the same plane are called as coplanar forces. To understand what are coplanar forces, let us try to take an example of this. We have four forces which are lying on the same plane, that is, they are lying on the plane of the board. Okay, So they are lying on this plane. So these set of forces, that is F1, F2, F3 and F4, are called as coplanar force. But if, let us say, there is a force which is in the direction of this pen, which is not lying on that plane, so that becomes a non-coplanar force. So the force which is in the direction of this pen becomes a non-coplanar force. So let us consider an example for coplanar forces. Let us consider that I am in a park with my two friends. If I observe myself and my friend from the top, I would see something like this: me, myself and my two friends. If my friends decide to push me, then you can see that there are two forces which are coming towards me, and since you are observing from the top, you see that the two forces are lying on the plane, that is on the plane of the ground. And since these two forces are lying on the same plane, they are called as coplanar forces. If we consider in this case the gravitational force which is acting on us, then in that case the gravitational force becomes a non-coplanar force with respect to the forces F1 and F2 which is acting on me. The non-coplanar forces are basically those set of forces which do not lie in the same plane with each other. So that is why gravitational force for this case becomes a non-coplanar force. Once we understand how to analyze the coplanar forces, the non-coplanar forces basically are the forces which are in the 3D model of the system. Planar forces are depending on the 2D model of a system. What do you mean by 2D and a 3D model? It basically means that all the forces, if they are lying on a piece of paper like coplanar forces, then that becomes a 2D model because it requires only the length and the width of that particular object. If the object is in 3-dimensional, if it has its depth also, then in that case we will require the analysis of a 3D model of the system. In that case we will be studying about the non-coplanar forces. So for now we are going to stick with only the coplanar force. Now let us see what are the types of coplanar forces. So we are seeing the types of coplanar forces. So first one is the concurrent forces. So concurrent forces means the forces which are intersecting at a single point, or they are originating from a single point or meeting at a single point, or all the combinations of that. So basically let us see. Okay, so to understand the coplanar force, let us try to understand this system. There are 5 forces in this system. All the 5 forces are on the same plane. They are on the whiteboard. So they are lying on the whiteboard, and you can see that they are meeting at a single point. So they are originating or meeting at that point. So that is why they are having a common point of intersection. So they are called as concurrent forces. So forces which are meeting or being projected from that point are called as concurrent forces. Let us consider an example for concurrent force system. Let us consider this as me, who is standing on ground. Now the forces which are acting on me will be passing through my center of mass, which is denoted by this blue dot. The forces which will be acting on me will be the gravitational pull and the normal reaction on me. Since you can see that both the forces are passing through my center of mass, that is gravitation force which is acting downwards and the normal reaction which is acting upwards, they are passing through the same point, that is my center of mass. These forces are coplanar forces as well as they are concurrent forces. So next type is the non-concurrent. So obviously from this it means that the forces which are not meeting at that point is called as non-concurrent forces. So forces which are not meeting at a point are called as non-concurrent forces. So a non-concurrent forces is basically a more generalized version. So because it will be dealing with a 2D figure, because in the concurrent force system it is only dealing with a point, the point, at that point what are the forces which are acting on it. In a non-concurrent system I will be dealing with the objects in a 2D fashion. So the force, the point of application of the forces which will be at different points, and the analysis will be accordingly done. Let us consider this example in which I have 5 forces. So the 5 forces, you can see they are not going to meet at any single point altogether. So that is why, since they are not meeting at a single point, they are called as non-concurrent force system. The third type is the parallel force system. So parallel as in the forces are parallel to each other, they are not meeting at any point and they are not intersecting anywhere. So parallel force system are basically can be of 2 types. If the forces are in the same direction and they are parallel to each other, so this becomes one type of force, parallel force system, and the other one is in which the forces are parallel to each other but the direction is opposite to each other. So that becomes another set of parallel forces. So these set of forces are called as like for parallel forces, and the other set, that is this set of, is called as unlike parallel force. Now let us understand what is called as resolving a force. So resolving a force, basically it comes when the problem is very complicated in nature, like we have more than 2 forces on certain object acting on a certain object, and we have to find the net resultant force or the net force which is acting on that body. So in those cases I require to resolve the forces into components along the x-axis and along the y-axis. So the x and the y-axis, as we go into the problems section, we will be seeing that they can be taken according to our needs. So basically x and y-axis are 2 axes which are going to be perpendicular to each other. So let me take an example in which I have taken this 2 axes as my x and y axis, and at the point of origin there is a force which is acting along it. So the force is having a magnitude of f, and the direction it is making an angle with the x-axis, a theta angle with the x-axis. Now we have to find these components. Basically, what are the components of this force all along the x-axis and along the y-axis? So that is called as basically the resolution or resolving a force along the x and the y-axis. So we have to find the values of fx and fy. To understand that, let me construct this triangle from there. So I am having f as a hypotenuse. The theta angle is one of the angle of the right angle triangle. You know the trigonometric ratio, that is cos theta is equal to fx upon f. So let me say this is my fx. So cos theta is fx upon f. So what will be the value of fx? Fx is f cos theta. So you got this value as fx is equal to f cos theta. If you want to find this, let me say this is my fy. So I have to take sine theta. So sine theta is fy upon f. So my fy will be f sine theta. So I have got the resolution of the force along the x direction and the y direction. So if a force is making an angle theta with the positive x-axis and I want to find the x component of it, then I have to just multiply the magnitude with the cos theta factor. So if I am multiplying f with cos theta, then that becomes the x component of that force, and if it is along y-axis, I have to multiply with the factor of sine theta, so that becomes my y component of that force. Now my force will not always lie in the first quadrant, it can be in any quadrant. So it can be in third quadrant, it can be in the fourth quadrant. So how can we resolve it every time? So every time we cannot draw this triangle for every force, because the force system can have, let us say, 5 or 6 set of forces. So every time the triangle drawing part is very difficult. So let me say in generalized form how to find the x and the y components. What I do is I take a pen, I place the tip of the pen in the direction of the force. Okay. Now, if my pen is rotating in the theta direction, like if it is going towards theta, then that component will be F cos theta. Okay, so whenever your pen is moving in the direction of theta, then that becomes F cos theta. If I want to find the y component now, since the y component is away from the theta, so that becomes my F sin theta component. Okay, so that becomes the magnitude part. Now what about the sign? Now you can see this pen is rotating in this direction, so I got this F cos theta, which is along theta it was rotating, so that is why I got F cos theta. Now see the tip of the pen, it is pointing towards the positive x axis, so that is why the sign for this is going to be positive. If this force is going away from theta, it had F sin theta component, and since it is pointing towards the positive y axis, this will also have the sign as positive. Let me take another example. So we are taking this another example in which my F is in this direction, it is making theta angle with the positive y axis. Now how do we take the component? So again the same thing, take the tip of the pen, place it in the direction of the arrow, and if you want my x component, I have to find this way. The pen should rotate in this way, so since it is going away from the angle, it will be F sin theta, and since it is pointing in the negative direction, it will have the sign minus. Again, if I want to find the y component, place the pen, rotate it, since it is going in the direction of theta, so this particular component will be F cos theta, and since the pen is pointing in the positive direction, it will have the sign plus. So that is how we simply do resolution of the force. So I have got this component of the force along the y-axis and the x-axis. So if I have multiple forces, then this becomes a simpler method to do it, to take the component basically along the x and the y.
Thank you for watching our videos. If you have any doubts, please do share in the comment section. For information on us, you can go and look it in the about page. It will also give you the schedule of the videos which will be coming up in the month. Do like and share and subscribe our channel. This will help us make more videos like this on different topics. Do watch videos on other topics also. Thank you and keep learning.